Okay, we're going to get started on the complex plane. So you'll be able to plot complex numbers, perform operations with the complex numbers in the complex plane, and use the distance and midpoint formulas in the complex plane. I think you're going to find this pretty simple. So if we take a look here, what I want you to notice is right here how they label the complex plane. You have an imaginary axis and a real axis. So what you should see is this is your real number, this is your imaginary number. Notice that the number is 3 and the number is 1. It's just 3, 1. You just do it straight up. And then the definition of the absolute value of a complex number is just doing that distance formula. Pythagorean theorem. Okay, so if we're going to go for this one, so first, if I plotted it, here is how I would plot it. -2 and 5 is where I'm at. And then remember when I told you how to find the distance? You go from here to here. And so, if I think about it, if I go from there to there, you can take a look and see that that is -2 or 2. And then the top one is 5. So really you're just using Pythagorean theorem. So it's going to be 4 plus 25. So therefore it is the square root of 29. All right, go ahead and pause. Give the next one a go. And as soon as you're ready, go ahead and pop back in. And the answer is 5. Let's go on to the next one. Okay, operations with complex numbers. You've been practicing graphing with them, and so that's all you're doing. Is the same thing here, is you're going to just do the same thing that you do with vectors. So here we're adding those two together. So to find 1 plus 3i plus 2 plus I in the complex plane, all you're going to do is, if you go, this is 1 and 3, so 1 and 3, and then this is 2 and 1. So if I do 2 and 1, that's this vector right here, which is this vector right here. So it gives you the resulting vector right there, which would be 3, 4, or the resulting complex number. Actually, all we're doing is we're adding our real numbers, which is 3, and our imaginaries. All right, so go ahead and give the checkpoint a go. Come back on when you're ready to go. And the answer is 4 plus 3i. Okay, here's subtracting two complex numbers. It's just like we've done before with the vectors. So when I go through and do this, if I plotted 4 plus 2, that's this vector right here. And then our other vector was 3 and -1, 3, -1, which would be this one. But we are doing the negative, so if we're doing the negative, that means you change its direction, which is why it makes it this one. And now we can just go through and do the process. So we've got 4 minus 3, that's your first part, plus, and then we've got 2 plus 1, taking that negative through, I. So we end up with 1 plus 3i, which is this point right here. Okay, go ahead and pause, give the other one a go, come pop back on when you're ready to see the answer. And the answer is 1 minus 5i. All right, cruising on to now. Okay, so now it says plot -3 plus I and its complex conjugate in a complex plane. Write the conjugate as a complex number. If you remember when we were doing conjugates, all you do is you take your negative. So you'll see here, this is our original and this is our conjugate. So all you're doing is you're changing your I. So your conjugate would be here. Okay, go ahead and pause and bring up and pop back on when you're ready to see the answer. And the conjugate is 2 plus 3i. Let's move. Okay, so now we're talking about distance formula in the complex plane. So really all you're doing is just the distance between those two vectors, which remember here, you're looking for magnitude, which is what we consider, what we call distance in the vector world. So if we go here and take a look at this one, again, remember I showed you how to do this, is you just make it a right triangle. And so this here is 3, and from here to here is 5. So all you're doing is you're using your Pythagorean theorem to find C, or find the hypotenuse. So we've got 3 squared plus 5 squared is equal to 9 plus 25, which gives you the square root of 34. All right, and now, of course, you can do the distance formula and use 2 and 3 and 5 and negative 2 as well, but that just makes things so much harder. All right, go ahead and pause and let me know when you are ready to do, or just pop back on when you're ready to see the answer of the next one. And the answer is the square root of 82. Okay, now doing the midpoint. The midpoint is just like you normally do. So you're just going to get your coordinates and then do the midpoint. Let's go. All right, so if I think about what my coordinates are for this first one, it's 4, negative 3, and then the other one is 2, 2. So I go 4 plus 2 over 2, negative 3 plus 2 over 2. I get 3, negative 1 half. That's your midpoint. All right, so go ahead and pause, and when you're ready to see the answer to the next one, go ahead and pop back in. And the answer is 7 halves and negative 2. All right, we are at the vocabulary portion. So in the complex plane, the horizontal axis is your real axis, and the vertical axis is, I don't have enough room, your imaginary axis. The absolute value of the complex number a plus bi is the distance between the origin and AB, and to subtract two complex numbers geometrically, first you represent them as vectors. The points that represent a complex number and its complex conjugates are really just reflections. They're reflections over the x-axis, or the real axis, I guess we should say. The distance between 2 points in the complex plane is the modulus of the difference of the two corresponding complex numbers. Okay, you're done.